Here's integrated 3. This is problem 10-129. This problem shows you a table, and it gives you a graph, or I mean not a graph, it gives you an equation, and it says what are all the intersection points of this function right here, this parabola, and the function given by the table at right, and they don't give you an equation for the table at right, and write your solutions in XY form. So one way, probably the way they wanted you to do it, would be just to start going down the list and checking solutions. That would, I mean, I really did not want to do that. So I did it a different way, and I'll share that with you. But one way to do that would be to plug in a -5 for X and see if you get a 42. And then like just go through and check each one. The fact that it says this table is a function, though, it made me want to find the equation that goes with this table. But the equations, I don't think it's super easy to find. I see it's not linear. I'm thinking it's probably quadratic. Made a few attempts, it didn't work. So I'll show you how I ended up figuring the problem out. If you don't understand any of what I'm going to say, just know that the other way to do it is just plug each of these in here, and the ones that work in here are the solutions. But here is what I did. I went ahead and did what I call curve fitting, which I don't think you know how to do curve fitting yet. Curve fitting is when you take some ordered pairs and you put them in your function and you do some systems of equations on it until you can find the coefficients A, B, and C. Since I really believe that this function has to be a quadratic, I feel confident. I mean, it has to be a quadratic because these negative, like, see how it's going up on both ends, even when it's like the negative numbers are turning positive, and the positive numbers there. It's some kind of squaring is happening, and I can tell it's a quadratic. So what I did is I just picked a couple points. I picked this top one, the bottom one, and the 0, 7, because I need 3 equations for 3 unknowns. The 3 unknowns that I have are the coefficients of x squared, the coefficient of x, and the constant. I knew the constant was going to end up being 7 because we got the 0, 7 here. So what you do is you plug it, you take an ordered pair, and you plug in the y for y and the x for x, and you kind of just boil it down, and then you go, before you do anything else, you go to the next one. This one boiled down nicely because when I plugged in zeros for x's, I ended up finding out that c is 7, which I can plug in here and over here. I used this ordered pair and, plugged in the 5, and I ended up with 72 equals 25 times 2 plus 5b, and I put the 7 on there because I knew that c was equal to 7. And so I kind of cleaned this thing up, and wait, no, I didn't. I took this one right here and I wrote it underneath the first one that I got, and I did elimination on it. That's when you add them together. So I'm not sure that, I don't really care so much that you can follow this math, but if you're interested in how to get the equation, I did elimination. I found out what A was. Then I took the A and I plugged, that's what I did over here. I plugged the A was 2 and the C was 7, and so I plugged in A to find A and C to find B, and I found out what A and B and C were, and so that gives me this equation. And then what I did is I stuck it in, well, first before I stuck it in Desmos, I did a system of equations, you know, like equal values method. And I ended up with x squared plus 4x minus 5 equals 0, and that factored out to x plus 5 and x minus 1. That's how I knew these are the two solutions. And when I look on my table, the negative 5 goes with 42 and the 1 goes with 12. So I know that's the answer that they're asking for. They're asking, this is actually the answer to the problem, by the way. But you can also graph it. I graphed the two parabolas. These are the two equations that I had, and I graphed them. And I just found out where they meet, like where they intersect. So negative 542, and I can tell they're probably going to intersect down here. Here's another intersection. And that's 112. So that's called, this whole procedure that I did to get the equation is called curve fitting, if you're interested in that. But I think at this point, you could have just, it wouldn't really take that. That took me a lot longer than it probably would have just to plug all these plug each number in to here. The ones that work are the solutions.